Uh, Good morning. Myself Abhinav Arela, and today we are going to discuss the 3G 4G wireless communication standards. And here 3G stands for third generation standard, and similarly 4G stands for fourth generation standard. So if there is a 3G 4G, definitely there was 1G and 2G. And to understand the importance and or the essence of 3G 4G standards, we have to first do a comparative study of 1G, 2G, 3G and 4G. So in the comparative study, first of all we take first generation technology, and it is one of the most basic technology, and this technology was basically analog in nature. When I say it's analog, it means to say that the modulation techniques were analog in nature, and the overall communication was also analog in nature. And this first generation technology basically was used for the purpose of telephonic communication. And the achievable data rate with this first generation technology was 2.4 kbps on average, which was quite low. And because of this low data rate, the quality of the voice was inferior. And the capability to resist the noise also was inferior, and so the reliability was less. Because of its analog nature, its capability to fight with the noise and its reliability was quite less. So the communication engineer feels the urgent need of some superior technology, and in the evolution of the superior technology, they switch from first generation technology to second generation technology. And we will see in second generation technology that apart from a telephonic conversation, we will have a voice over the digital channel. We have the capability to access the packets or to access the internet. We can have a different application with the higher data rate. So now we will discuss the second generation technology. There were some limitation with the first generation technology. First limitation was its data rate. It was around 14.4 kbps at max and 2.4 kbps on average. And second was the quality of voice. So in the case of first generation technology, quality of voice was quite inferior, and the reliability with respect to the voice signal was very low. So there was an urgent need of some superior technology. That's why communication engineer evolved second generation technology. And in second generation technology, we have a better reliability, we have a better voice quality, and we have a better data rate. So let's see second generation technologies or underlying technology members. And the second generation technology, first member is the GSM, and GSM stands for Global System for Mobile Communication. So the first member was GSM, and the achievable data rate was 10 kbps. But the difference with the first generation technology and the second generation technology is that in case of first generation technology, the voice was analog or the signal were analog, where in case of second generation technology, the voice is digitized and it is communicated over the channel. So now that voice is present in the digital domain rather than the analog domain. Once we have the data in the digital domain, it is very easier for the communication engineer or for the implementers to combat the noise. So the quality of the noise increased, the reliability of the channel increased, and if we further move down to edge, the data rate will increase. So now consider the second member of the second generation technology, that is your CDMA, and its CDMA stands for code division multiple access. So whether it is GCM or GSM or whether it is CDMA, these are two different technology evolved at the same time, and both were capable of providing the data rate up to 10 kbps, and the voice signal was digitized. Basically CDMA, it is code based technology, whereas GSM is combination of FDMA and TDMA, where FDMA stands for frequency division multiple access, whereas the TDM stands for time division multiple access. But whether it is GSM, whether it is CDMA, both evolved at the same time around 1990s, and both were capable of providing the data rate up to 10 kbps. So the quality increased, quality of the voice increase, reliability increase, but there was some application those required the data rate beyond 10 kbps, like online gaming, like video conferencing, like high definition TV and real-time communication. All these technologies requires a data rate greater than 10 kbps. So communication engineer kept on evolving, and the new technology evolved, that is known as GPRS, and it is under the category of 2.5G. GPRS was the first technology that was capable of providing the digital communication, as well as it was able to access the packet from the network. If I say that it was ever able to access the packets, it means to say that it was the first technology that was capable of accessing the internet. So with the help of GPRS, you can access the internet, any web page, any web content. But once again, the 50 kbps was not sufficient. Because of this insufficient in the data, the quality of experience was very inferior. So once again, the communication engineer kept on evolving, and they evolved a new technology, that is your edge. So next technology was your edge, and edge stands for enhanced data for GSM evolution. So basically it is not a new technology. it was the evolution of GSM technology. We have changed our modulation technique at the physical layer or at the hardware side, and with the change in the modulation technique, we were in a position to achieve the data rate up to 200 kbps, which is quite significant with respect to your GPRS or CDMA. So in true sense, we can say that the 2.5 generation technology was the first technology through which we can access the internet, through which we can access the packet network, or we can say that with the evolution of the edge technology, the quality of experience has improved tremendously. But this data rate was only capable of to give the better quality in sense of retrieving the data from the internet, but there are some applications like video conferencing or like gaming online or real-time communication were still not possible with this particular data rate. So it was exactly the breakthrough. And in the second generation, it was the last technology. After this technology, we have to shift, the communication engineers shift to the third generation technology, and which has better data rate, better technology. So now we are going to discuss the third generation technology. So with the beginning of edge, communication engineers were in a position to achieve the data rate up to 200 kbps. But there was an urgent requirement because of some application, real-time application like video conferencing, online gaming. So communication engineers shift from second generation to the third generation. So we are going to discuss the third generation technology, and we will discuss its member. So in the category of 3G, first member is your WCDMA. It stands for WCDMA stands for wide band code division multiple access, and the underlying technology was UMTS. UMTS stands for Universal Mobile Telecommunication System. So with the enhancement of the hardware, modulation techniques, and with the evolution of the different sets of frequency, now we are in a position to increase our data rate up to 384 kbps. So in true sense, up to one generation to second generation, our communication was narrowband, but when we switch to the 3G standard, our communication becomes the broadband. So whether we call it third generation technology or we can call it broadband. So in the true sense, the third generation technology was real broadband, and we were in a position to achieve the data rate up to 384 kbps. So it can satiate the demand required by the application like video conferencing, online gaming, or real-time communication. Another member is CDMA 2000. It is also once again code division multiple access, and it was evolved or developed around around the year 2000. That's why it is termed as CDMA 2000. Both were technology capable of providing the data rate up to 384 kbps. But the breakthrough in the 3G technology was 3.5G, and the 3.5G was HSPA. That is, HSPA stands for high speed packet access. high speed packet access. So it has its own version. First one is HSDPA and HSUPA. Here HSDPA stands for high speed downlink packet access, whereas HSUPA stands for high speed uplink packet access. So these are for the uplink and downlink communication, but this technology has a speed up to 5 to 30 Mbps. So it was exactly a breakthrough in the data rate, and the level of or the quality of experience kept on increasing from second generation to third generation to 3.5 generation, and it has a parallel technology 3.5G, that is EVDO. EVDO stands for Evolution Data Optimized. So all, whether it is CDMA 2000, HSPA, EVDO, all are the family members, and they were capable of providing the data rate up to hundreds of kbps to some of 30 up to 30 Mbps. So here we can see that the significant change in the data rate. So now the quality of our experience kept on increasing, but still there are some application which require higher data rate than the 30 Mbps. That was your high definition TV and the online gaming. That's why the evolution of the technology, that is known as fourth generation technology, evolved, and now we are going to discuss the fourth generation technology. In case of fourth generation technology, basically we have two players. First one is LTE, that is your long term evolution, and it was capable of providing data rate from 100 Mbps to 200 PS, and basically LTE stands for long term evolution. It is basically evolution of the UMTS technology. So there is some improvement in the UMTS technology that leads to the LED. And another key player is in the 4G technology is the WiMAX, and it was also capable of providing the 100 to 200 Mbps. But with the WiMAX, the underlying technology was OFDM. In case of GSM, what we got to see that we were using the FDMA, TDMA. In the case of CDMA, the technology was basically code dependent, but with the evolution of the fourth generation technology, we come to the technology that is WiMAX, and the technology to implement the WiMAX at the physical layer was OFDM. With the help of OFDM, we were in a position to achieve the data rate up to 100 to 200 Mbps. With this data rate, the application is high definition TV and online gaming. But the basic difference between the 3G and the 4G technology is that in case of 3G technology, the network was used basically circuit switch network, and packet switch network. In case of third generation, where in case of fourth generation it was always packet switching. So if I try to differentiate between the packet switching and circuit switching, whenever there is a communication over the circuit switch network, the communication always reserves the resources and the packets have the priority for the communicating parties, where in case of packet switch network there is a no priority, the network is random and the resources are not reserved. So in that case the optimization of the data is more with the fourth generation technology rather than the third generation technology. And the last point in case of fourth generation technology is that the connectivity between the base station and the user was more, even though the user was on move. So we can realize that nearly 5 to 10 years back, when we used to travel with that train, our connectivity basically lost, or our mobile connectivity basically lost, but today our experience is far good with respect to our previous experience. Still we find a connectivity while the train is on run. Okay, thank you very much.